Hello, everyone. If you'll go ahead and get your seats, we're going to get started on our panel session. Okay, good morning. My name is Navneet Meschani. I work at the Aerospace Corporation, and I am pleased to present you the panel discussion this morning. Dr. Ed Kearns, unfortunately, could not join us today. He sends his regrets, but we look forward to a very engaging discussion with our panelists who are here. We thank them very much, and also our moderator, Ms. Marilee Wheaton. Before I introduce Ms. Wheaton, just wanted to do a recap of how this panel session works, as Rick had mentioned earlier. Sorry, phone distracting. There are no cards on your table, so please formulate your questions. Marilee will open the panel by posing some questions to the panelists, and please formulate your questions, write them down, bring them forward. There'll be people in the aisleway, and we will filter them and weave them in live. Ms. Marilee Wheaton. She is currently a Systems Engineering Fellow at the Aerospace Corporation. In this role, she leads multiple collaborative cross-organizational teams aimed at developing innovative, resilient architectures, assessing new model-based systems engineering processes, and assists in establishing knowledge management systems. She has been with Aerospace for a while and has held numerous leadership positions related to ground systems, including being the general manager of the Computer and Software Division and the Systems Engineering Division. Most recently, she was the executive director of the Aerospace Institute. She has a bachelor's degree in mathematics from Cal Lutheran University and a master's in systems engineering from the University of Southern California. In addition, she is a graduate of UCLA Executive Program in Management. She is a fellow of the AIAA, fellow of the INCOSE, and a fellow and life member of the Society of Women Engineers. She has served as an adjunct faculty in the Systems Architecting and Engineering program at USC. With all this, we are very excited to have Marilee back again as our moderator. Please join me in welcoming her.
Thank you very much for that introduction, Navneet, and good morning to everyone. Very excited to be moderating our panel again. We have a very wide breadth of expertise up here in various different areas related to ground systems. So I am going to start by introducing each of our panelists and asking them an opening question. And then, as Navneet said, please start entering what questions that you would like to ask the panelists. And we hope to spend most of the time answering the questions that you have on your mind. So first, I'd like to introduce Colonel Dennis Bythewood. Colonel Bythewood is the director of the Remote Sensing Systems Directorate here at SMC in Los Angeles. Before he was in this role, he was commander of the 50th Operations Group at Schriever Air Force Base, where he was responsible for more than 1,000 military and Department of Defense civilian personnel serving in 6 squadrons and 1 detachment. That unit performed around-the-clock global satellite operations on more than 60 satellites across very diverse orbital regimes, providing warfighters and other users worldwide with position, navigation, and timing capabilities, military satellite communications, intelligence, surveillance, reconnaissance products, and environmental and space situational awareness. Colonel Bythewood received his commission in 1992 after he graduated from the University of Vermont with a degree in electrical engineering, and he also holds a master's in business administration from the University of Colorado, Colorado Springs. His career has included numerous acquisitions and satellite operations positions in the Air Force Space Command, Air Force Materiel Command, and the National Reconnaissance Office. So, Colonel Bythewood. And what I would like to ask Colonel Bythewood is, obviously GSAW is all about ground systems. It's in the title of our workshop. But we definitely have heard this year about the needs for a new level of collaboration across space and ground segments. We certainly heard it this morning from our keynote speaker from NASA. So that new level of collaboration across space and ground segments, networks, and other systems in order to build that most resilient systems. So I would like to ask Colonel Bythewood, what would you think would be an example of that new level of collaboration that you are seeing or planning? And also, what do you think needs to change in order to have that new level of collaboration?
Absolutely. So I think if you look at ground systems as we have in the past, you tend to look at them within the stovepipe of the mission area, that we execute. For remote sensing, that could be either our environmental monitoring side or our missile warning. But when I talk to U.S. Stratcom, they could really care less about my focused mission area. What they care about is how the enterprise works together to deliver a warfighting capability. And what missile warning does for us, right, is provide us the time to react. And that is not just a remote sensing problem. That is data gathering, data exploitation, data sharing, right, and then a command and control mix that all has to come together. So even within my own program office, looking at our issues within just a satellite to a ground system to an operational site isn't adequate, right? It is how do we pull all those pieces together to get actionable information to the command and control authorities. And so when you look at resilience within that pocket, you have to look at each one of those spots and how those interactions happen. So the example in our case would be, I utilize MilSatCom to push data. That's needed. I utilize terrestrial communications that are not even military to push data. That's important that we're resilient in all those spots. The easiest spot to hit me may not be the one that I'm defending against. And so when we look across resilience at, writ large, it is having those red teams look at where can I come and stop you from doing your job, not stop you from getting that piece of satellite data from that satellite, but from doing the mission writ large. And that enterprise look is critical, that we take that and look across the entire architecture to make sure that we're defending against those pieces. Thank you.
Thank you. Our next panelist is Mr. Jim Kagi. Mr. Kagi is the senior manager and leads the U.S. Department of Defense solution teams for Amazon Web Services. He's been delivering highly distributed web-scale services to enterprise customers in the commercial and U.S. federal sectors for over 10 years. At Amazon Web Services, he is responsible for the Department of Defense solutions development and enterprise architecture. Prior to joining AWS, he spent 12 years as an infantry officer in the United States Army and completed multiple combat deployments to both the Middle East and Afghanistan. So, Mr. Kagi, you work in the area of IT and in the IT world, and given all the innovation that we're seeing in the IT world, and we certainly have heard it throughout the presentations that were given here at GSAW, what IT trends and future directions do you believe will most impact resiliency of ground systems, their architectures, and their data?
Yeah. Thanks for having me here. It's really exciting to be able to participate today. So at Amazon, me and my team, we're focused primarily on warfighter mission support systems and how we can enable the warfighter to do more of the data that's available to them and make better decisions quicker. That's kind of our mission statement. That's a key tenet of what we're working on in my team at Amazon. And as part of that, we've obviously been investing a lot of time and energy in understanding how to bring more autonomy to the military, right? And that's just not just from a warfighter perspective, but when you look at it from a systems perspective as well. Once you start introducing artificial intelligence, machine learning, deep learning, once you start introducing that into weapon systems, you start introducing that into ground stations, which are processing a lot of data from space, from full motion video asset, sensor collection assets up in the air. Once you start collecting data from many different endpoints, sometimes thousands, if not millions, of military sensor endpoints around the globe, of course, you need to ensure that it's great that you're using artificial intelligence to process all that data, but another use of autonomy and machine learning is actually to help keep the system operating efficiently. And we've learned in AWS that once you get to a certain scale, traditional monitoring techniques are not always going to predict where your next failure is going to occur. In fact, you could do there's a lot of probabilistic analysis you can do. There's a lot of mathematics you can put into a problem of trying to understand when something's going to break or when something is going to potentially have an issue once you reach a certain scale. But at the end of the day, there's just never enough humans to really do the deep level analysis that you need to do in order to predict where the next failure is. So that's where unsupervised machine learning algorithms and models come into play. And so we're spending a ton of time investing in not only how we keep our cloud services resilient, and how we use AI to monitor, detect issues, predict when the next failure is going to happen. We're not only using that technology internally, of course, to keep everything up and running, but then we're also helping the military understand how they can use those same techniques to keep ground stations, and in some cases, we're actually talking to various entities in both the DoD and intelligence community to keep global systems, right, ISR systems, operational and intact and cyber resilient, right? Cyber resilience is a big thing right now. So how do you keep things secure as well? And so that's some of the. So that's, I think, from an IT trend perspective. And we could talk about this more later, and I'm sure some other panelists have some opinions on this too. But there's just a ton of potential in the use of machine learning and unsupervised learning algorithms and models. And so yeah, thank you.
Next panelist is Mr. Cesar Lindo. Mr. Lindo is the Program Area Manager of Satellite Operations and Ground Systems within Boeing's Commercial Satellite Constellations Business Unit. Since 2016, he has been responsible for general software development management for commercial constellation ground systems, which includes the Iridium Ground Development and Support Program. Before his most recent assignment, Mr. Lindo was the program manager for the upgrade of the Iridium Next ground system, which integrated the new Thales satellites with the current ground system. The system was modified and scaled to include the ability to fly up to 140 satellites to accommodate the transition from Block 1 satellites to the new Block 2 satellites. The new system also provides the capability to seamlessly use two separate C2 command and control products. In addition, the software provides for a lights out capability, allowing the Iridium customer to operate the constellation without additional staffing requirements. Mr. Lindo received a Bachelor of Science degree in Aerospace Engineering from NYU Tandon School of Engineering and a Master's Certificate in Project Management from George Washington University. Mr. Lindo, the theme of GSAW this year was achieving the resilient enterprise. And so what does resiliency mean to you with regards to your mission that you're trying to conduct there at Boeing? And what do you envision when you think of a resilient enterprise? And how might you quantify and measure aspects of resiliency?
Well, thank you for inviting me to this panel. From a commercial perspective on Iridium, resiliency means maintaining the maximum serviceability across all the service offerings that Iridium has. That is achieved by a flexible architecture that's been implemented. Iridium is a very good use case. It's been around 20 plus years. They are still flying their Block 1 vehicles as they launch and replace their current constellation with the Thales vehicles. They are up to 40 right now. That system over that 20-period time has evolved. And it's an architecture that has been implemented to reduce single-point failures from a hardware-software perspective, but it also maximizes the autonomy at all system levels, including taking the operator out of the loop, which is key. So in every aspect that we have an opportunity to remove the operator out of the loop, we've done it across the board. That has reduced our operator errors and in turn has increased our system availability. And then the other key aspect of our architecture is the evolution of that architecture. As you deploy the system, you learn how to operate that system more efficiently. You look at opportunities to see how you could diversify, disaggregate your system to provide better service, better flexibility when there's downtimes, et cetera. And that's been key to the Iridium success, not only on the ground side, but also on the space with modifying bus software and payload software to come up with different modes of operations and offer additional new services that weren't even thought about at the beginning of the program. Now, how do we measure resiliency? From a commercial point, we're looking at service availability. So every service offering that Iridium offers is measured and is as baseline of availability. And if there's any degradation in that, that is run down in terms of the root cause and figuring out what is causing that degradation and resolving that. But then they take that further in terms of analyzing what in the system has caused that degradation in the service, and then changing the architecture and implementing new ways of operating where we not only eliminate that service, but also eliminate that service degradation, but also looking at other service components to ensure that that same profile does not reoccur.
Thank you. One kind of follow-up on that same topic. If you thinking about this transition to the Iridium Next ground network, what would you cite would be the major resiliency improvement from the original Iridium network that you had?
I think one of the major things that we've done on the Iridium network is our teleport network, where we had TT&C sites that were dedicated for TT&C, and then gateway sites that were dedicated for our revenue-bearing traffic. That network was re-architected. All those assets on the ground in terms of the earth terminals were put in a pool, and they could handle either service or TT&C traffic. And that gave us the ability to disaggregate the assets on the ground and also reroute traffic, whether there's a weather impact or hardware impact, and that's been a significant improvement there.
Thank you, Ms. Lindo. Our next panelist is Dr. Barry Clifford Newman. He's the director of the Center for Computer Systems Security at the Information Sciences Institute at the University of Southern California, and he holds a research faculty appointment in the Computer Sciences Department at USC. He received his bachelor's degree in computer science and engineering from MIT, and then he spent a year working at MIT on their Project Athena, where he was the principal designer of the Kerberos authentication system. Dr. Newman began graduate studies in the Computer Science Department of the University of Washington, where he received an MS degree and also his PhD degree from the University of Washington. Dr. Newman's research interests include issues of scale and large distributed systems. He has proposed the virtual systems model, a scalable approach to organizing large systems, and he is the author of the Prospero Directory Service, a prototype directory service based on that model. The Prospero Directory Service organizes data from distributed internet file systems and information services into a coherent whole. Dr. Newman has applied the virtual system model to managing resources in distributed systems. The Prospero Resource Manager forms the basis of the network computing infrastructure that schedules multiprocessor resources in the broader context of distributed systems. So in addition to this research interest in issues of scale, he has been conducting research in computer security even longer. And as I had mentioned, he was one of the principal authors of the Kerberos authentication system. Professor Newman, so let me ask you again about our theme of achieving the resilient enterprise. What does resiliency mean with regard to communications capability? And what do you envision when you think of a resilient enterprise? And how might you think we should quantify and measure that resiliency?
Thank you. So when I think about resilience, I'm looking at the ability to meet a mission objective or an operational objective of a particular infrastructure. In spite of the inevitable failures that will occur, whether those failures are due to simply failed components on a random basis, or whether those failures are due to cyber attacks or an intelligent adversary trying to bring down the system. In looking at the question of resilience, the metrics that we apply are quite important. So I'm going to take this a little bit out of order. When I look at a metric that one might apply, one metric is not, is this system as itself just capable of providing these services, but I like to look at it in terms of for how long into the future will this system be able to continue to meet that operational objective in spite of a potential failure or a potential attack that might occur. That metric is something that actually changes over time because it depends on the situational awareness of what's going on in the system. One of the areas that we have looked at operational resilience in is the energy system. So if we look at the power grid, for example, you look at the current generation capabilities, you look at various other factors, and the fact that you might have a cloudy day, you're getting less generation from solar, is going to affect the period of time at which a particular component might be able to operate if it were disconnected from the rest of the grid. So you need to look at these kinds of issues now in the context of a communication system. Now, things are a little bit different when we look at our communication systems. One of the techniques that we use to improve resilience in energy systems is energy storage. Battery backup, generators, and the idea is that those can fill in for a certain period of time when you are disconnected from everything else. In the communication systems, the idea of storage is a little bit different if you think about the problem in the context of being able to have an instantaneous channel to communicate. However, the problem becomes a little bit more similar if you think about a different operational objective. If the operational objective isn't to establish communications, but instead to communicate information to an endpoint, now you can achieve, in some sense, that kind of storage through pre-staging, through caching, through the movement from a link-level system to a network-level system where you're applying more store and forward, as we heard from our keynote speaker this morning. You can take that one level up and start to look at the application level in terms of being able to pre-stage data, send it out to different components where an otherwise disconnected component may be able to pick up that information. So these are the kinds of things you need to look at in terms of establishing resilience. That is, defining what the operational capability is that you need. Is it simply instantaneous communication, or is it the delivery of information? You might also look at it in terms of, we heard discussion of autonomy before. We might be able to design some of our end systems so that they can make decisions on their own when they are disconnected from a communications capability. That also goes into the issue of operational resilience, maybe not purely of the communications capability, but when you look at what is enabled by that capability.
We're very pleased to have our final panelist, who hails from Germany. ESA has been a part of GSAW, and in fact is on our advisory panel for, I think, some 20 years, so we're always very pleased to have folks come join us from there. Mauro Pecciola is the head of the Operations Center Systems Infrastructure section of the Data Systems Infrastructure Division in the Department of Engineering at the Operations Center for the European Space Agency, which is in Darmstadt, Germany. He has more than 30 years of professional experience in the mission operations domain, initially focusing on the management and execution of spacecraft operations, and later on more specifically on the definition and production of ground data systems. Mr. Peccioli, you know, this idea of a multi-mission enterprise capability, and I think this is one thing that in our European partners really excel at, this idea of doing multi-mission types of projects. Is this idea of multi-mission enterprise capability at odds with the traditional ability to add special protections or safeguards for a particular mission? And if this new approach of using multi-mission enterprise capability has these benefits, how do I convince the seniors in my organization that this is something that we ought to invest or go forward on?
Good question. Okay, as you said, we in ESA have a long tradition of designing our ground infrastructure in a way which can be used for a variety of missions, and in particular we look after all the type of missions that we need to operate from the ESOC center in Darmstadt. These are LEO missions, which are characterized typically by short visibility passes and short propagation delays. Then we have also astronomy missions, which are very similar in the way of being operated to GEO missions because they are characterized by long visibility passes and also short propagation delays. And then we have deep space missions, which instead have long propagation delays and long visibility passes. So this type of different missions lead to different operations concept. However, we have always tried to design our systems in a way which accommodates the needs of this variety of missions in a single implementation, which is a way for us to achieve, if you want, resilience by heritage, because every time that we do a new mission, it's not a new infrastructure or a new design or a new approach. We are basically reusing largely what has been already used by other missions, and you minimize the effort in specification, in conceptual design, and also you minimize the risk because you are reusing a large part of systems which have already been validated by previous missions. So now, is this the best approach for doing systems on ground? For sure, it is very beneficial in terms of synergies, in terms of, as I said, also risk minimization. It has also, naturally, obviously, drawbacks. One is that you rely on a very complex governance process because you need to put in place two parallel lines of developments, the line of the infrastructure and the line of the individual missions that need to have a lot of interaction points. And also the fact that you extend even longer the lifetime of systems, which are typically already quite long in the ground system. You have decades that need to be survived for a given mission. If you are talking about an infrastructure, in order to be justified, it needs to have a critical mass of a large number of missions that uses this, which further extends, therefore, the lifetime of this infrastructure. So in a world where technology is very quickly changing, how do you maintain an infrastructure for 30 or even 40 years in place from the point when you conceive it and design it up to the point when it can be disposed? And then also it creates a sort of a slowdown effect in embarking in new things, in new solutions, because when you have something which is very well established, you don't rediscuss it, and the operators, they are very cautious in going into a new solution which is not as well proven, as mature as the previous one, and therefore you have a sort of effect where basically you are competing with yourself in order to introduce a new solution in place, and this slows down even further than normal the adoption of new technologies and new concepts.
So thinking about the this multi-mission idea, here, you know, we are doing work on EGS, or the Enterprise Ground System, and this question is for Colonel Bythewood. That came from the audience. With the RS systems being planned to use EGS in the future, can you describe what key challenges you think face RS in terms of transitioning from legacy programs to this new architecture?
Yeah, so from an enterprise systems standpoint, you know, the remote sensing systems directorate is looking at I'll call it two pieces, you know, within our, what we call our future operationally resilient ground enterprise. And that is both the mission data processing end, and then what, you know, the standardized TT&C piece. The TT&C side of that is absolutely being driven towards the enterprise ground services. And I'd say the biggest challenges for us as we make the move is similar to any mission area, whether that be commercial, you know, or DoD, is you've got an ongoing, you know, required mission set that has to be delivered day to day, and you're trying to move that infrastructure, as we just talked about, underneath it, right, to the next level. So there's some institutional resistance, right, to taking a risk as you move forward, even though the benefits of making that jump are, I think, well-founded. So for us, as we look at it, is how do we make sure that we ensure the continuity of services that we're providing to the warfighter today throughout that entire transition, which causes us to carry, our legacy system that we're still building out as we move forward to a more open architected, EGS-based provider. And so what that requires us to do is keep those two things linked together during that period of time, that as we move forward on an EGS services standpoint, that we're working with our current contractor base and our current mission partners so that each one of those critical services is transitioned smoothly as we go through, which is going to be a challenge for us to maintain that. And to be honest, I think one of the other challenges that we always have as we make any kind of a move from one system to another is you reach a point where you want to lock the legacy system down, so that you can very cleanly transition those capabilities forward. And you're trying to do that in an environment where our adversary gets to vote and they don't lock down right on their end. And so managing that transition is going to be just as difficult for this program as it has been, right, for everyone. And what I'll say, the environment that's different now than I've seen in the past is when I hear folks like General Wheaton and General Raymond talking about the operational risk that they're willing to take as we drive through those transitions. In the past, it would be, I don't want to take any operational risk, but I want you guys to drive as fast as you can on the acquisitions, the requirements, and the other side of the process. But what I'm seeing now is an entire look at, a revisit of how we look at risk across the enterprise, knowing that we have to take risk in order to move quickly, and we have to balance that risk with the mission assurance posture that we need.
This next question from the audience is to any of our panelists or all. I think I'll start with Dr. Newman, since he had mentioned this. It's related to automation and autonomy, and then the folks can weigh in as well. So, definition of automation is a system that executes procedures with little or no supervision. Autonomy is a system that decides what procedures, including those not yet defined, that need to be executed. So how does the panel envision using analytics and machine learning, which have been mentioned quite frequently during this GSAW, to support automation, leading into autonomy in a contested environment where the goal of an adversary may be to lead an autonomous system into a desired decision that may disrupt, degrade, deny, or destroy that system. So as we utilize automation and autonomy, how do we balance that in what we know is a contested environment? So Dr. Newman, if you'd like to start, if you'd like to weigh in on that.
So first of all, let me state my background is not artificial intelligence. But I will comment on really what the goals of some of that autonomous operation should be. And in particular, when I was talking about autonomy, the idea was making the system overall, the operational goals, resilient in light of a failure of the ability to communicate with the human controllers. Okay, so that's really what you're trying to achieve with resilience. Ability to operate in the absence of things that might otherwise be there is the resilience that we're looking to achieve. Now, one of the goals that, and I'm not necessarily speaking about a military environment in this case, but one of the goals that I think is extremely important to focus on when we look at autonomy in systems such as, let's say, autonomous vehicles, for example, is really the safety property. That is, you need to characterize what your hierarchy of goals are. What is most important? What is less important there? And it is very important that the architecture of your system, and now I'm not talking just the communication system here, but the system itself, is designed in such a way that certain of those goals are unchangeable. So one of the big concerns that I've got if we look at autonomous vehicles is the fact that we're going to have inevitably in our vehicles the same kinds of patching mechanisms where software updates will be downloaded into these systems, and that creates a subversion vector, the ability for someone to compromise the system by compromising those update characteristics. What you need to do in designing such a system is design it architecturally so that there are certain functions, certain goals that cannot be updated over the air. So that you can't push out this kind of update. Now, in some sense, the whole idea of a software update over the air is almost this concept of pre-storing future communications. In other words, you're anticipating what are the kinds of decisions I might make in the future, and you're saying, okay, well, I'm enabling you to make that decision in the absence of communication. But you need to understand your goals and understand which of those you want to preclude from being updated, pre-pushed out in some sense.
Here and then.
Okay. Yeah, so just to add on to that. So I mean, I think definitely from a military operations perspective, of course, yeah, there's a lot of risk, right? And once you start introducing more autonomy into systems, into military operations, into tools, right? Tools of the trade, vehicles. But as part, again, adding on to what Dr. Newman said, from a resiliency standpoint, as you're building these systems to be self-healing and to have a certain amount of level of awareness, so that if parameters change, if something about the environment changes, or if the system's about to do something that it wasn't intended to do, that there's a check and balance built into that system. Now, in some cases, that's built right into, if you think about a vehicle, a vehicle might actually have two circuit boards. They might have one circuit board that is learning, it's making autonomous decisions, and then there's another circuit board that's actually saying, thou shalt not do these two things. And that second circuit board may have the ability of actually overriding, right? There's that type of level of architecture. There's also the whole concept of having a sentinel, like a monitoring system that's independent of the system that's that's autonomous. And the idea of the sentinel, or the idea of the monitoring service, is to actually to be a canary, right? To actually check on that other system to see, is it doing what we intended it to do? And if it's not doing what we intended it to do, let's go and correct that. So it provides a continuous improvement mechanism, so that not only is the autonomous system continuously learning and learning about its environment and making decisions, but there's also another check and balance. There's this other system there that is, again, maybe it's doing software updates, but maybe it's not doing anything other than just making sure that this other system is actually operating the way we intended it to operate. And if it's not, there's process and technical things you can do to improve that system or get it back on track. And from a technical perspective, that monitoring system can go forward and make another update to that system or shut it off. And then from a process perspective, you can introduce human-level processes and checks and balances, so that, of course, in the military world, right, we're obviously not in a place right now where we want autonomous systems making command and control decisions. We're not there, and we're probably, we're not going to be there anytime soon, right? The autonomous systems, models, AI is not built enough trust with military decision makers, right, to be able to make command and control decisions. So there's always going to be a human in that loop somewhere. And so when you start thinking about process improvements to autonomous systems and ensuring that they're doing what you want them to do, right, we're going to keep the chain of command in place. And of course, adversaries are always going to try to exploit weaknesses, but there's a human factor, and there is some redundancy and some fail-safe mechanisms that we put in.
Mr. Paccioli?
Yes, I wanted to comment from an operations point of view. As you know, our main focus is on spacecraft operations, and we are indeed embarking on many initiatives to automate what the operator currently does manually. And I have an opinion that we should more invest in removing the need of automating, in the sense that remove the need of operating at all. That's the best way to automate. In the sense that, for example, today we have learned that there is this link layer management, which is very intensive. Every time you do a pass, you need to manage your link, you need to do a lot of things. You need to prepare, plan, schedule. If you miss your pass, you're not in a good situation, because your spacecraft didn't receive the commands, you didn't get the data, and you need to reschedule everything, you need to replan operations, you need to reschedule the next pass. It's extremely intensive. To do all this and automate all this is a big investment and does not necessarily introduce a level of resilience. We should instead make it resilient at enterprise level. Avoid the need of replanning in case of passes which are missed. And that would simplify enormously the way you can operate. And we have learned this morning from scheduled network passes to unscheduled passes. That would really change the world. Not that we replace a machine with a human with a machine. We need to simplify the way we access our resources. We need to simplify the way we get data from our resources. And that will simplify enormously also the need of automating.
Thanks. I have a follow-up question here as it relates to these increasingly autonomous systems, but it has to do with collaboration between commercial and government, and certainly in the vision this morning that our keynote speaker from NASA provided us, you saw a lot of that wanting to standardize across and kind of use across the enterprise between commercial and government. So as we think about enterprise systems spanning data acquisition, forecasting to decision support, how can the government and private sector collaborate to assure operations of increasingly autonomous systems? So maybe Colonel Bythewood, you might want to start, and then maybe Mr. Lindo, you might think about that as well too.
Sure. So, I mean, I think you can look at it, in various parts of the infrastructure. We talked about, pooling resources within Boeing for the Iridium system to make sure that you've got a wider access and can fail over into what is the most important thing at the day. And I think you can look at that same kind of infrastructure as between commercial and government. Where does the government line up with commercial infrastructure so that we can utilize I'll call it in a benign environment, a wider set of tools, and then fail down, to a much narrower set of protected, apertures, when the need arises. And you could look at that the same way when you look at cloud infrastructure, the ability to take advantage of a large amount of dislocated processing, but then also be able to fail down to a set of tightly controlled, and protected assets as we go forward. And the only way, in my mind, that you can adequately do that is that the standards, that we're using to integrate between those different layers are lined up in such a manner that that's not a complicated failover, right? It's back to simplifying the infrastructure, simplifying the interactions, so that we can make use of more things across. So instead of having a highly protected, stovepiped set of infrastructure, you are opening the aperture to being able to use a widely diversified and proliferated set, and then fail down as you go gracefully to the core set of mission capabilities that you need.
Mr. Lindo?
So the other thing I want to add to that is one of the lessons learned we experienced as we implemented automation, because we did not start off that way. We gradually introduced it by mechanizing majority of the activities, and then we started slowly automating in every sector. But that's a cultural change. You have to gain the trust of your leadership, your operators, et cetera. And I think one of the things that the commercial and the government sector could do is a lot of collaboration in seeing how they've implemented, how they changed the process, because it is a process and cultural change, and trying to learn from that and see how they could implement it on the government side.
Mr. Kagi, in terms of Amazon Web Services, you certainly have to work across both domains in terms of commercial and federal. Any ideas related to autonomy, increasing autonomy, or supporting autonomy across that interface?
Yeah, I mean, so we're of course, we're, first of all, interoperability is so critical. I mean, the keynote talked about it this morning. In order for commercial government, in order for AWS, right, to be able to support all these mission workloads that, both our commercial customers have business workloads, and they have things that they're delivering out to consumers. They also have things that they're doing to make their business better. But then on the government side, of course, we have real critical mission workloads, and they need that to operate, on a platform. They need that to be, they need their application to be able to interoperate with things that may be in the cloud, may not be in the cloud. So we focus really, really strongly on supporting, open standards, open protocols, open source technology, and ensuring that, if we introduce a new application programming interface, that's well documented, and that essentially that becomes a contract, right, between us and our customers. And then, from an autonomous system perspective, interoperability is so critical. Of course, that system itself, right, in order to be resilient, it's going to be self-healing. It's going to have a certain level of awareness. It's going to have a certain level of redundancy. It's going to be able to operate in a degraded state to a certain extent. But again, going back to that other example I talked about earlier, some systems, right, they are not always aware that there's something that's abnormal or not nominal, and they need to be told, or they need to be improved upon. And of course, in an adversarial environment, the conditions are going to change, whether that's because of an enemy, whether that's because of a human error, whether that's because of something environmental. Things are going to change. So if you have an interoperable system, then you can share data, or you can update the system, or you can communicate with that system in a way that's well understood by many different vendors, by many different government agencies, and that's just absolutely critical. So from my company's perspective, we love collaborating with government standards boards and bodies. We love collaborating with NIST. We love collaborating with with all of our other commercial partners. I mean, we love collaborating across industry. We do a ton of work with both Microsoft and Google and Apple and Facebook to ensure we're able to interoperate with each other in a way that is encouraging resiliency across systems and across the industry. Thanks.
Much of the resilience discussion this week has been about topics about building cyber protections, autonomy, as we've just discussed, different architectures. But we also need, of course, focus on the users of our systems, or the warfighters and the operators that have to execute with usable technology. So we were talking previously about resiliency metrics, and the question is, why isn't user experience one of the resiliency metrics, or if it is, how might we focus on those needs for the users or warfighters? So, would anyone like to start on that?
I see that no one else wants to answer this one. Why we don't make the resilience metric based on user feedback?
Right.
Because it would be too negative. No, especially in our environment where, as I said before, we are basically producing systems which are distributed across multiple teams. You always have different opinions, and something which is a firm belief of one user is contradicted by a firm belief by another user. So it's not necessarily the user should not be taken as the Bible in all cases. However, yes, user feedback is essential, and especially when you're developing new systems, you need to involve them as soon as possible in a way that you are designing the systems in the way they expect, and the way they expect is the way they're familiar with. Every time that you try to phase in a new system, they always come back and saying, I want to have the same as the previous one. And that applies to any generation, which means they always prefer the previous one. Mm-hmm. So this gives an evidence that they prefer the one they know. Right. It's not the quality of the system essentially which makes a difference, but it's how much they are familiar, how mature is the deployment of that system in the environment which needs to be used. So that can be anticipated in the sense that you need to do early deployments, you need to provide the user with visibility of preliminary versions and not only the final version, a long transition where they acquire, they familiarize, and they can provide feedback. So the DevOps concept also involving the user as one of the ends of this process. And then, of course, face as was said this morning as well, the virtue of being patient and wait for them to like it.
Yes, all very true. Mr. Lindo?
So, I think it's important to make a distinction between simply user experience and user interface. And if we're looking, and the question I think had to do with user interface. If we're talking about user interface, it's then necessary to make a distinction about who exactly are the users. So when we look at infrastructure and the interface to that infrastructure, one would almost think that the interface is what's viewed by almost the operators of that infrastructure, as opposed to the end users of the services provided for it. So, again, I've been doing a lot of stuff in the power grid. The interface for that to the end users is you plug in your device. Okay. However, there are operators at energy control centers that are responsible for ensuring the resilience of that infrastructure. And in some of the work that we've done, we've looked at providing tools so that they can have a measure of resilience and then choose from different alternative mitigation strategies when something occurs and actually run simulations in order to determine how that changes that resilience metric in order to make a decision. So in that case, user interface to the system operator would in fact be something that is critical. But user interface to the end user, ideally the end user's experience is either the infrastructure was resilient or not, and ideally that it was. So it's important to understand that interface to whom.
The only other thing I want to add is listening to the end user and understanding what is valuable to them at the end of the day is very critical and very good information to take back and see how you can improve your services, your availability, and also offer different types of solutions, because they're going to be looking at different ways to apply that data and potentially better ways to architect your system in return. So I think it's very important to keep them in the loop.
Colonel Barthur, you mentioned about operations, and resiliency, and thinking through, to that impact on the operations. Any additional thoughts related to that aspect?
So I kind of echo the operator in many different facets, right? So I think when we look at resiliency, there's certainly the operate through side of it. There is the rapid recovery of capability side of it. And so, when I look from a resiliency standpoint, you certainly get into I'll call it the maintainer, right, side of the business, which is when something fails, because it will, how have we ensured that the interface to that person, right, or that system, right, that has to drive the recovery is intuitive and can be executed quickly with what we will expect is a lack of data, right, at the time that when you most need it. So I think that is one piece that we have to clearly think about of, as we do this graceful degradation, how are we recovering, and how have we enabled that interface to drive that? The other side, I think, when you look at what we standardly look at as an operator is, where in the chain of operations do you want to focus, right? So in my line of work on the missile warning side, I could say that the 460th Space Wing operator, right, is my customer. Well, they're really not, right? They're an operator of my system, and they certainly are a customer, but they are not the customer, right? The customer in the end rolls down to the Stratcom commander, the Northcom commander, who is looking at not only my data, but a myriad sources of data to make a decision. All the rest of us are supporting that decision. And different operators within that line are really decision support aids, right? So how do we make sure that the system, from not only in my stovepipe, which is still a stovepipe, is providing interoperable data with the other systems that feed that decision, right? Because when I go out, it's not that the system's down. We have radars out there that are looking. We have other systems that are looking. But you can't have lost a chunk that makes the rest of the system inoperable and not able to move. So you really need to look at what is the decision we're trying to support, and how do we support that in the best way that doesn't require that guy to have a PhD, right, in order to make the decision, that we're providing those right tools.
Thank you. Speaking of decision-making, we have a question actually related to that. And it's, what opportunities do you see to use advanced analytics to act as a force multiplier for human decision-making, particularly as we think about achieving resiliency goals? So again, it's advanced analytics related to human decision-making. And maybe we'll start with Mr. Kagi, if any thoughts related to that?
Yeah, I mean, so right now, I mean, there's, again, kind of what I began my initial talk about was, there's a lot of data out there right now. There's a ton of data. There's more data than any one human or even any one system can process. So you need to, and there's tons of things, whether it's a sensor or it's a computer system generating that data. It could be log data. I mean, right now in Amazon, to give you a quick stat, I mean, we're generating exabytes of data in Amazon just to maintain and operate our internal systems, let alone all the data that our customers are generating and storing on our storage services. So when it comes to an analytics perspective, leveraging big data analytics clusters and taking advantage of massive compute, massive scaled out storage capabilities in the cloud is super critical, because now you can start making better predictions again, getting back to something I talked about earlier, things that could potentially fail. And from a data center operations perspective, we're always looking at, when's the next hard drive going to fail, right? And of course we have millions of hard drives, so we know, we can tell that it's any given point in time there's going to be 100 hard drives dying somewhere in the company, right? But getting even more deeper into that, right? We're looking at, because of the scale that we're at, we're starting to see some things operationally that no one in history has ever seen before. We have some services now that are servicing out hundreds or billions of requests per second, And so there's latent bugs in software that can occur, there's hardware failures that can occur when you get to that level of scale. And so big data analytics is so critical because it gives humans, right, a signal, right? With all that noise going on and all that log data, it helps to distill what are the things I really need to be paying attention to? What are the things what are the kind of the metrics that I need to start paying attention to? What are the leading indicators that something's about to happen and go wrong? And then you create this feedback loop because, you understand what normal is right now, but normal is going to change over time, right? As you scale out, as you add more hard drives and more servers, or as you improve your software, normal is going to change over time. And so by having an analytics system that's constantly analyzing what things look like, not yesterday, but right now, that provides a feedback mechanism so that now you can re-baseline normal, right? So now you have better metrics, so you understand what the leading indicators are that something is going to fail today or tomorrow. And then you're continuously improving on that, right? So it's just a continuous cycle of, all right, new normal, okay, we're going to need better metrics. And now that you have better metrics, you got better alarms, you're fixing those problems ahead of time, but oh wait, here's a new thing we've never seen before, and you're continuously improving on that.
This next question has to do with challenges that we see in terms of achieving a resilient enterprise. And of course, there are, obviously quite a few challenges in that area. And I might ask our panelists to be thinking about what they think is that particular resiliency issue that might keep you awake at night, or the one that you're really trying to currently solve. But this next question related to challenges asks about two areas in specific, which is what are the challenges and how are you addressing them of keeping up with configuration management and security protection while increasing resiliency? So, Colonel, would you like to start with that one?
Sure. I'd say the challenge, and it's a big one across everything, is just getting started, right, on any of these things. And so, when you look at configuration management and certainly the security aspect of this, it is not trying to do one size fits all, annual or every 2 years updates to systems, right? So, for us as we design, the ground system architectures and the interfaces between system, it's being able to rapidly adjust to what we're seeing live. And our historical, answer of we do ground system updates once a year or twice a year, is inadequate, right? I mean, the adversary's not working at that pace with us, and we need to stay forward. So that drives, I think, two pieces that become interesting as we look at risk. One is, I certainly can drive my team to be doing monthly, weekly, or daily uploads. But I also then have to drag the operator along with me to say that those monthly, weekly, or daily uploads don't drive risk into the system that they're operating day to day. And that's a collaborative environment of trust that we have to build, as we go forward. And we're not there yet, right? When I bring a new drop into the system, I still have to convince everybody that I've done the work that I need to do in order for that thing not to be the reason we fail. And so I think that is a challenge that we continue to run through, and have to make sure that we're designing our architectures in that way, right? So that we can adequately flesh out these updates at a rapid timeline to provide assurance that when we're dealing both from a configuration management and a security update standpoint, we can do that in a mission assured way.
Dr. Newman?
So I think one of the important things to keep in mind is that any large infrastructure is a federated system. That is, you have multiple entities that are involved with different goals. And this is especially the case when we look at, the ground system architectures for things like the International Space Station or any international collaborations that are coming into play. And that's certainly going to create an issue for configuration management, because you are not going to have a single authority that can impose the same regimen on all the endpoints. As was pointed out in the keynote this morning, you also have insiders that are sometimes adversarial. And that creates an additional issue for configuration management, especially from the perspective of things like software subversion. That is, can there be intentional changes that are made to components of the system that can degrade resilience in other cases? And that needs to be considered.
Mr. Pecciola?
I would like to answer on the question, what keeps me awake in the night? I would say the complexity, the ever-increasing complexity of the systems that we have to manage. And this seems to be a trend which is continuous, and technologies help in some respects, but not in all respects, to keep it simple. So I think we should all invest more. Has been said very well this morning, I have to say, with this over-engineer your architecture in order not to over-engineer your systems. You have to invest more in creating an enterprise which is resilient, and to keep your individual elements of the enterprise simple enough to be managed and to be agile and to be not these big elephants that every time you change something you need a 1 million effort to revalidate everything at the same level as it was before. So we need to really, I believe, invest in simplicity at the implementation level by investing in complexity at conceptual level. So you need to really create the conditions for your operations, your systems, and your setup to be simple.
Mr. Lindo, would you like to share a resiliency issue that you're particularly, a hard problem you're working on, or something that keeps you awake at night related to your?
Well, I think to add to that, I think one key thing is to have a sustainment plan for each segment of your ground system and be committed to doing that and balancing that out on delivering your mission needs and being able to do that cost effectively and stay ahead of the game is a key thing.
Mr. Kagi, any?
Not necessarily something that keeps me up at night, but I think what we're always worried about in Amazon is innovating faster. Can we innovate fast enough to keep up with our mission owners and our customers? And again, there's our customers, and of course the DoD, the intelligence community, and just commercial industry, there's a lot of innovation going on out there across the globe. And as a tier 0, tier 1 infrastructure service provider for these commercial and government entities, we have to keep pace, and we have to stay ahead. In many cases, we have to stay ahead of our customers. So what we get really focused on in Amazon is how do we decentralize? How do we push down ownership to the lowest levels so that we can speed up innovation? Now, one of the things we've done we did this in our company about 15 years ago, is we moved to this concept we call 2 pizza teams, right? The idea is that your team should be no larger than what it would take to feed them with 2 pizzas. And again, we didn't really invent this concept. We actually, quite frankly, we took a lot of the organizational things we do in Amazon. We lifted them from the space industry. There's a lot of great lessons learned from the Apollo and shuttle programs. But yeah, we created this 2 pizza team concept, and so the idea is that if you're going to deliver a new service, it could be a microservice, it could be a standalone service, it could be a service that's part of a very large service, if you will. You're going to own that service, and you're going to define your inputs and outputs for that service, and you're responsible for the integrity of that service and keeping that service up to date. And of course, you have business level goals that are given to you, and some of these are given to you based off of Amazon business priorities, but a lot of them, quite frankly, they're based off of customer feedback, right? Working backwards from the customer, what is it that we need to deliver today? And so what we end up doing inside the company is each one of these 2 pizza teams, whenever they're thinking about a new service that they want to deliver, they'll write a press release, FAQ, before they even write any code. And the press release is going to be what we would want to release a year later, or 5 months later when the service is out there, what we want to say about the service, what challenge is it solving, who's the end customer, what is the customer trying to do. We put fake customer quotes in there. It's like General Wheaton is super excited about the new Amazon storage service because it cuts his cost down by 50%, right? Whatever that is. And so that sense of ownership, right? First of all, defining what the customer problem is, defining that first, right? Making people accountable and own that system, and also making them accountable for not just developing the service. Here's one more interesting thing. They're not just accountable for developing the service, they're accountable for operating the service. So very often in software development shops, you write the software and you throw it over the fence, and someone else goes and operates that. Within Amazon, it's the exact opposite. If you build the service, you're also going to operate the service. There's a strong sense of ownership there. And I think, getting back to some of the comments earlier, I think, both in industry and government, there needs to be a cultural shift towards decentralized ownership, right? You can't own everything at the top level. It's impossible for any one 4-star or CEO to own everything that's going on, but they have to, and quite frankly, they don't. They trust. They delegate down to the lowest level. That's what we do in the military. That's what we do in Amazon. That's what commercial industry does. So, it's culture is super, super critical. Any time that you're going to introduce change and you're going to innovate.
Kind of going along with this theme of challenges, so can you speak to the unique challenges associated with maintaining data resiliency? For example, accuracy, availability, security, given the ever-increasing data volumes, data variety, retention requirements, data velocity, and geographic distribution. I think this goes to the complexity that Mr. Peccioli was talking about. So anyone like to give some thoughts related to maintaining data resiliency with the ever-increasing capabilities of the system and complexities that we're...
So I'll comment on a few things because that gets sort of smack into the middle of the area of security, where we look at things of confidentiality, integrity, and availability. Most of the discussion that we have been having so far with respect to resilience has had more to do with really the availability side of that equation. But certainly, if you look at the mission objective of distributing information, your integrity and your confidentiality is probably part of that mission objective. Now, fortunately, we have a number of technologies that in a fairly disconnected way, that is, not having to have a great deal of interaction with the availability side of things, can help us protect the confidentiality, can help us protect the integrity. Basically, our checksums, hash functions, cryptographic hash functions, and in particular, cryptography with respect to the confidentiality. So some of those issues which are part of the mission objective in terms of resilience can be addressed in sort of a isolated way. We apply these technologies. You then need to, of course, focus on the availability aspect. Now, in so doing, there is one interaction with some of those other components, in particular, the integrity aspect. If information is changed, the technology that we have to assure integrity merely tells us the information is not what it originally was. So changing information in this manner, we might know it's not the information that was originally produced. That ties in a little bit with the availability side, because now you don't have the correct information. You also have integrity that comes into play in terms of, well, I used the term several times already, software subversion. That is the integrity of the system itself rather than just of the information. And that needs to come into play and be considered as well in terms of the measures that we apply.
Any other thoughts on data resiliency?
I mean, it's obvious. I mean, I'll just one quick comment. It's obviously super, super critical for everything we do in the cloud services business, and of course, cryptography and automation are just absolutely really critical. As Dr. Newman said, when you start looking at confidentiality, integrity, and availability, you have to have humans are going to make mistakes, and it could be a maintenance mistake, could be a security mistake, it could be a lot of things, but those mistakes can obviously cause issues with the integrity of your data. And so going with that mentality from the get-go that something's going to fail and that humans potentially can make mistakes with our data, that kind of drives you towards automation. Where can we automate, and then where can we put the right checks and balances in our software development life cycle so that we're not introducing latent code mistake or issues with code and mistakes. And one other key critical point. So I talked about the importance of decentralizing and encouraging innovation and all that, and how we innovate new services. There are some things that you probably do want to keep a little bit more centralized, though, and specifically the way that you apply cryptography across your services. The service team or the team that's really good at building widget XYZ is probably also not very good at building crypto modules, for example, right? So there are some things you absolutely want to consider to centralize a little bit more in your organization and in your development pipeline.
Mr. Peccioli?
I wanted to say that there is, of course, the problem of protecting and confidentiality of your data, but there may also be the opposite problem, which is that you want to make your data available, at least within an organization, but for scientific data it might also be of interest to the external world in the long term. So how do you maintain the data in a way that can be accessed in a meaningful way using technologies which are the ones of the time when you access it, and accessing them in a way which is meaningful to the people who are accessing it at that time and not at the time when they've been produced. This is a huge issue that I don't know the solution, I'm just saying this is the other side of the problem. You may have the need of accessing data and you do not have any access because they are stored in a way that is not accessible any longer. You don't know where they are, or you don't have the application any longer, which is able to process those data in a way which makes it intelligible to you. So that's the other problem.
Yeah, so just to follow up, and I agree with you entirely on this. When I typically teach confidentiality, integrity, and availability, I specifically say that oftentimes the techniques that we use to protect confidentiality go specifically against the techniques that we use to provide availability. That is, the data that is more available is available to more people, and therefore is going to likely be less confidential. Now, we can apply cryptography, but even when you apply cryptography, you've still got the issue of making the data available through key management, and that gives availability of the keys and diminishes the confidentiality. So confidentiality and availability are, in some sense, opposite ends of a spectrum. You need to draw a balance in terms of how you manage the data.
One of our working groups this week actually was working on trends in artificial intelligence and machine learning and how that can help us for, as we think about achieving resiliency and enterprise ground systems. So this question deals with that. So how do you deal with the evolution of intelligence systems where the actions and behavior of the system evolves through artificial intelligence and machine learning over time? Do you have any thoughts on that? Mr. Lindo, are you, in terms of the systems you're building, evolving toward with these areas?
Well, one of the things that we do have implemented is first layer of machine learning, in which we try to do weather predictions, for example, in terms of our ground sites to try to move traffic away from that and be proactive and not wait for an outage there. We're also looking at doing machine learning in terms of our system and our processes, on being able to predict when something's going to go down and do pre-maintenance on something that we could maintain availability on and things like that. But I think we're in the early stages of that from an operational level, and there's a lot more to do, a lot of trust that needs to be built, and knowing how to implement that is, I guess, the next step to take advantage of that.
Getting back to the topic of collaboration, and I think because we have this good mix across industry and commercial and government, this question says, how would you like to see government adapt their acquisition processes to allow greater collaboration with industry and agile development of resilient systems? So, that was your time to offer up how you think a suggestion for the government that might allow for this greater collaboration. Any ideas in that realm? Would you like to start, Mr. Lindo?
So I think from that perspective, we have a lot to offer on the commercial side in terms of how we've implemented automation, how we've leveraged an architecture and have evolved it in terms of quickly ingesting new technologies into our system. And I think that has given us the ability to improve our system availability, reduce our cost, and also the ability to be able to do multi-mission operations and large fleet operations. And I think the ability and speed in which we implement technology is something that we could collaborate on how to do it in a safer manner.
Mr. Kagi, any thoughts related to, what you might offer up would be something that would help with acquisition processes related to government?
Yeah, yeah, there's. I don't want to sound like a broken record, but obviously there's still a lot of room for improvement in IT acquisition, right? I mean, we all know that in this room, so I don't need to repeat any of that stuff that's probably been discussed already this week, and everyone just well knows and understands. So there's definitely room for improvement there, and there's been encouraging comments from Congress over the last year and how they're progressing in that regard. So, but just in general, from an acquisition perspective, one of the things we focus on, right, is training and education in new technologies and what's coming out, what's the cutting edge, what's bleeding edge out there. I think training and education is really important because it helps acquisition officials and procurement officials start planning, right? Because obviously with government budgets, you have to plan, many months, years ahead of time. So the more education and the more training that we in industry can provide our government counterparts, and then vice versa too, right? Us in industry, we need to listen to our government customers and understand their mission better. I need to understand your mission. I need to understand General Milley's mission over there in the Army. I have to understand the mission so that as we start innovating on new things, we have those ready to go when the government's ready to acquire them.
Colonel Bythewood, if you think of it from then the opposite side of the coin in terms of how you think what industry might be able to do to further the collaboration and improving on the government side of the systems, any thoughts there?
I'd say the biggest feedback that I tend to get is that we don't talk enough from the government side, right? So making sure that we are open on where we're going, what problem sets that we see in the future, I think allows industry to put their resources and their people against the things that matter to us, rather than the things that they think matter to us, because we've kept our mouths shut for years and years. So I think part of the collaboration is actually talking, right, and having that open discussion.
Thank you. So I'd like to, we're getting toward the end of the panel program. I'd like to end with one final question that I'd like to ask each of the panelists to think about. So, our GSAW 2018 theme was Achieving the Resilient Enterprise. And when we started on Tuesday morning, General Thompson was here. And he talked about what he thought was, in order to have a more resilient enterprise, that we should maybe think about taking some more risks or leaning forward, right? And so he kind of characterized that as running, that sense of running. But he said, not running with scissors, right? We all remember him saying that. So this idea of running, taking appropriate risks, leaning forward. So I'd like to ask each of the panelists, and I'll start with Mr. Peccioli, and we'll work our way back this way, is there one thing that you would recommend that we take a risk on in order to lean forward and therefore more able to achieve the resilient enterprise that we're looking for? So, Mr. Peccioli?
Tricky question. One thing, I would go for the network new generation architecture which has been presented this morning. It's really something which I believe we are missing in terms of new technologies. We should ask ourselves which of the ones which are offered, which are by far more than what we need, are really essential for us. And the ones which are pushed by, or pulled rather, by the missions in terms of mission objectives, they are normally materializing. The ones which are not, then we need to, because they are applying to all missions and they may bring a bit of benefit individually, but a massive benefit to all. These are normally the ones that you have to be very careful in selecting, because it requires a large investment. If you think about networking the space infrastructure, it is a big investment. It requires a lot of collaboration and commitment by everyone. So we should really select the ones which are promising for us and not just jump on anything which is offered by the market. So I think, I repeat myself, whatever brings simplicity in the way we will manage our assets is something we should invest on. And what I've learned this morning is certainly in this direction.
So I'd like to mirror that a little bit. I think looking at some of the next generation architectures that have been described are important. And in some sense they're described as next generation architectures, but the basic philosophy is the same philosophy that was applied to the ARPANET back in the 60s. And this is where the risk comes in, or where they should be willing to take risk. And that is, don't be afraid to rely on well, we'll use the term from the ARPANET, unreliable technologies, and we could say less resilient technologies, as the underlying capabilities, as long as your higher level architectures are designed to be resilient in spite of the lack of resilience of the underlying technologies. It creates greater simplicity. It creates actually stronger resilience at the higher level, because if you designed your higher level system to use only resilient underlying architectures, ultimately you're going to have failures in those underlying architectures anyway, and you just wouldn't have designed around those issues.
Thank you. Mr. Lindo.
I think one of the key things that we like to focus on is taking advantage of microservice architectures and enabling a clouded architecture. I think going forward for at least on the commercial side, it gives us the biggest flexibility in distributing our systems and disaggregating our capability to provide the most flexibility and security aspects for our missions.
Yeah, I think, obviously in warfighting and even in commercial industry, speed matters. Speed matters a lot. So agility is really, really critical. And, one of the things we do in Amazon to kind of decide whether, something's a risk worth taking is we kind of look at things from the concept of is it a one-way door or is it a two-way door, right? If it's a two-way door, then let's go take a risk. Let's go give it a shot. If it doesn't work out, we can roll back. And that's the same thing that we do in DevOps with software development, right? If we get the code out there, let people kick the tires on it. That doesn't mean deploy 100% across production and put it, put people's lives in danger. But let's get it out there. Let's try it out. And if it doesn't work, if we have the ability to roll back, great. Let's roll back and let's try again. But let's speed up that process. I think that's really, really critical. Now, a one-way door, those are the ones you want to be very careful about, right? That's when you overcommit resources, or you try something that's so risky that there's no way to recover from that. No matter what door you're going through, you're gonna spend resources and time on whatever it is you're taking a risk on. So as long as you have the data and as long as you understand how you're going to roll back, it's typically a risk worth taking.
So I think the things that we've talked about here, and I'm sure have been talked about all week. Over engineering the architecture so that we can simplify the underlying pieces becomes critical. And for me, when I look at it, that allows us to innovate on the components at a much faster rate. Because it's not that that I've now set up a system that I have to be failure free. It is I expect failures, and I've designed the architecture to work within them. And I think you can look at that on how the government has laid out every one of our, I'll call them tier 1 systems. They are designed to be faultless rather than fault tolerant, right? And those are the pieces that we really have to drive and take risks on as we move forward.
Very good. Thanks to everyone for the panel. We're ending a bit early, but it'll give folks a little bit more time at the break and some more networking time, which is always a great thing. Or if you'd like to come up and chat a bit, the final question you might have for our panelists, feel free to come forward and chat with them. I want to thank all of our panelists for participating and sharing very honestly and candidly their thoughts and ideas related to achieving a resilient enterprise. So thank you to all.